Hello, folks. This is doing a cluster API walkthrough on the 28th of September 2021. We're going to spend 90 minutes just going through some of the core controllers. So it's not super prepared. So you might, those watching recording might need to skip through, hit forward or whatever. We'll see how this goes. All right. So yeah. So first of all, those who don't, we have the cluster API book. Most of you seen, and believe we've got the descriptions of the controllers. So we'll go through. We've got I hit our first. This page is still being written. Stay tuned. Yeah. So cluster API is all of our core controllers are in this repo here, which I think most of you know. So we'll get that open up. Oh, I do have it open already. There we go. So in terms of code organization for the cluster API repo, we're mostly following what's been delivered by the Kube Builder project. So Kube Builder. So Kube Builder is if people have used Operator SDK previously, sort of Kube Builder was based on that. And I think they've sort of converged now. Gives you a structure for writing Kubernetes controllers, essentially. And then that uses controller runtime. So controller runtime is basically how all of our controllers work. We'll go through some of how that works in a minute. But in terms of how then the code is structured, is we have APIs defined in API directories, which are then versioned. So I'll just go through how we'll go through the basics of that. We'll probably do conversions in a follow-up because they can get tricky with some of the stuff we do around migrating versions. So the APIs are just Go structs. They have annotations on them, which are documented in the Kube Builder book. So you will see like / optional. Yeah, so we've got all these Kube Builder based annotations. So to see any of the meanings of those, you can see them in the book. One of some of the interesting ones you'll be looking at are sub resources. So status always sub resources, print columns. I think we should. So people on the CatRe project might want to take a look at the print columns because I don't think we've defined them on the CatRe controllers. So if you do a kubectl this get on the CatRe resources, you don't get a lot of information. So you might want to take a look at some of the other people who are working on CatRe, or if you're working on bring your own host, have a think about the user experience, about what you want to show to end users easily. So, and that's going to be controlled by this print column. So in terms of the rest of the code organization, we then have the controllers directory. So this literally has different controllers. So for cluster API, we have a core controller, and this core controller includes a controller that manages cluster resources, the ones that manages machine resources, machine sets, machine deployments, and machine health check. So that one's all in the core controller. We'll go through what those little controllers do in a bit. Control plane includes, so the control plane controller in cluster API has manages the Kubernetes control plane of workload clusters, and if it's self-managed management cluster, that's based on kubeadm, and that's essentially its own little controller. So the idea why it's separate is for not everyone wants to use kubeadm to manage their Kubernetes clusters. So in particular, Red Hat uses their own orchestration, so they don't use kubeadm at all. So they don't necessarily want a kubeadm controller running as part of core cluster API. We then have the Bootstrap controller. The Bootstrap controller, when we go into details of how machines actually bootstrap, it's probably most relevant to where to talk that, but the Bootstrap controller basically makes a machine execute kubeadm ultimately. So it controls the startup of machines. And finally, we have one, is there? Yeah, so we have one last one, which is hidden deep within test infrastructure Docker. And this is the controller for cluster API provider Docker. So the reason it's down here is that originally the Docker provider was only intended to be used for end-to-end testing. But now some folk use it for other bits and pieces. So that's why that's a thing that exists now. So it's currently in there. There's been some debate about moving it out or doing something with it, but that's currently how it's arranged. So it has its own API folders. So yeah, so this control plane has its own API folder and etc. So that, and then finally we have the CMD directory. So Cluster API, AWS both have a CMD directory, and that's for binaries essentially. So binaries that might ship alongside the controllers have their own directory essentially. So and we're using Viper, which is the standard. Is it Viper? No. Cobra command. That's why. Yeah. So we're using Cobra, which is the standard framework for building CLIs in Go. Right. So in terms of how a controller runtime controller works, we have the main.go, and in that we the first thing you do is we add the Kubernetes scheme. So the scheme is a sort of Kubernetes client that understands various API types, essentially. I think that, I don't know, I mean, that's my understanding of it. So I might not be talking the exact terminology, but that's certainly in my head how I've been thinking about what the scheme is. So it's a type of Kubernetes client that knows what a cluster looks like and knows how these various objects look like. We have a bunch of flags. We try and standardize these across the project. So they just let you turn on other bits and pieces. And then all of the controllers that you'll see have this common startup pattern where this is all sort of a framework provided to us by controller runtime in which we create a new manager. That's why you always see whenever you're getting logs from Cluster API, you're getting logs from manager. So we create a manager and then we essentially register things into the manager to then start. And this one's had quite a bit of code organization, so it's probably not immediately obvious. Yeah, so we have the setup of the reconcilers. So we add reconcilers to the manager. So those are the different controllers: the machine controller, cluster controller, MachineSet, machine deployment, machine health check. We use this. We have an ability to enable feature gates, and we use feature gate machinery from Kubernetes itself. So that allows us to turn on or off different reconcilers. Which ones are experimental still at the moment?
Do you want an answer? So
cluster resource set is still experimental, is it?
Yeah, and cluster class and maybe also machine pool.
Oh right, yes, that's right. Yeah. Yeah, I forgotten to mention cluster resource set or MachineSet and machine pool, and that's because I'm not super familiar with. I've not used them much. myself. So, and then finally, we have the ability to register webhooks on this manager. Yeah, so we have that. So, which are going to be CRD conversions, defaulters, and validation webhooks. Started to move away from using defaulters and validation webhooks for reasons to go to in a minute when we go to the API directory. And then finally, this is relatively new, but we just add some health checks to essentially check that the webhooks are running before we mark the controllers ready. Please raise your hand if you've got any questions. It's going to be fairly free-form. Right, Ashutosh.
I don't know if this question is relevant, but I didn't see this V1 beta 1 API type. Like, is this yet not made into CAPI?
It probably is. It is. I'm working off an older branch.
Okay, no problem. Yeah, that's why I got confused. I was aware that it made into the CAPI.
Right. Okay, so yeah, so there you go. So got the V1 beta 1. Yeah, no, sorry, I was working off the V1 alpha 4 branch because I was doing some work on that branch, essentially, doing some end-to-end tests, which I think we'll probably do in another meeting. So yeah, so for Kubernetes API, we always have something called a storage version. So think about probably the best explanation of this, I think, is on the Kube Builder page somewhere. Here we go. So if it's good to have an understanding of how these, I'll make a note of this. Right, so etcd is a database that stores JSON, and that's what Kubernetes is using. We need a way, if we have multiple API versions, we need a way to be able to read or write them, because you might have a user is going to be upgrading from one version to another. Secondly, you might have an old Kubernetes client that only understands an older version of a resource and might request. So you might have something that layered on top of Cluster API that only understands V1 Alpha 4, and it requests a V1 Alpha 4 API object in V1 Alpha 4, but the core Cluster API controllers are running in V1 Beta 1. So how does this happen? So we for every custom resource, there is a storage version, and that's always called a hub. So storage or hub version. So it's the version that is stored on etcd at any moment in time. So it's the actual blob of JSON on etcd is going to be in one version and in one version only. Caveat to that is when you're doing an upgrade. So I believe during an upgrade, the conversion is done whenever the resource is got. So as a client requests a resource from the API server and it's in the wrong version, it will get converted. But essentially, as far as the API server is concerned, there's only one type of version stored on etcd. If someone is trying to get an older version of resource, or we're upgrading resource, we need to do a migration, just like if we're working with SQL databases, we need to, and we added something new to our product, we need to do a database migration. So it's kind of same kind of thing, except we don't have all the same sort of referential integrity ideas, models that we do in SQL, we don't have the full rollback possibilities like we do in SQL. So one of the caveats around this is that you never downgrade a Kubernetes resource. Once you've changed the storage version upwards, you can't really go down. I believe that's true. Well, you can try, you will lose data is the end result. You probably might let you, but in principle, once you've upgraded, it's a one-time operation. Because what happens in terms of the API surveys, say if you've done an upgrade and now, so you've had a bunch of v1 alpha 4 versions of objects, you now fetch a v1 beta 1. You're now running as v1 beta 1, the storage res of v1 beta 1, and you get a cluster called test. Kubernetes API server goes to etcd, fetches that resource. That resource is now in v1 alpha 4. It's like, how do I know this is correct for v1 beta 1? At that point, it's going to call a conversion webhook on our controller. So that's defined in the CRD. So we can see if we have a look at the probably easiest ways to look at the release. I'll take Kappa one just because it's there. Yeah, so if we take a look at this infrastructure components, and then it opens up in the wrong editor, and move it to the right editor. Tell it it's YAML. Right. Yeah, so we have in the definition of the custom resource, this is just one of the resources that come with Kappa, a conversion strategy webhook, and it's going to call the Kappa webhook service on, and it's going to call it on this path /convert. The API server then sends some additional paths, like depending on what version's being converted. It will form like different requests, and it will call different request endpoints. In terms of how then that's implemented, I guess so. I guess we are talking about API conversions a bit. You do your conversions from the spoke of the hubs. So the hub is your center, like a bike wheel. So you are now in Cappy, our hub is v1 beta 1, and then we have different spokes that are either converted to or converted from. So the conversion, so when I was first getting my head around this, I assumed all the conversions would be in this v1 beta 1 area, but they're not. The conversions are in essentially the older versions. So in each of these, we have a conversion.go. We also have a ZZ generated.conversion. So we have some automatically generated conversions as well. So there's a tool called conversion gen that can read the API directory and convert between different versions. But what it's basically inspecting the types and saying, so what does a conversion mean? So if I've made no changes to my CRD, there's not really anything to convert other than changing the version number. So, and that's mostly the case for v1 beta 1. So v1 beta 1 is mostly the same as v1 alpha 4. In fact, at the moment, it's completely the same. So if you look in this conversion.go, there's not a lot going on. So what does it do? So we have this version v1 alpha 4, we're converting to, so we're converting a v1 alpha 3 cluster to a conversion hub. So we're converting it to a v1 beta 1 cluster. And what does it do? It takes the, we just create, well, we cast the conversion hub as a v1 beta 1 cluster, and then we call this convert v1 alpha 4 cluster v1 beta 1, and this is all in automatically generated code. And I think in mostly what is happening is it's just moving the structs over from one version to another. Nothing else is happening. And then but if we look at v1 alpha 3, then gets a little bit more interesting. So in this case, we are converting a v1 alpha 3 cluster to v1 alpha 4 cluster. And yeah, first of all, we basically do the automatic conversion, more or less. But then after we've changed some stuff. So we made changes in v1 alpha 4 and now v1 beta 1. So we're converting to v1 beta 1, but the changes that are here were mostly done in v1 alpha 4. So we have to do some manual conversion. So the automatic conversion mostly works when the fields are the same, where it's easy to imply what, but anytime we've deleted a field or we've added a field, we need to do something about it in the conversion. So if we've deleted a field from, say, v1 alpha 4 to v1 beta 1, then you get a problem when if someone there's an older client, so I'm a v1 alpha 4 client, I expect v1 alpha 4 version. I fetch a resource from a storage version v1 beta 1, but v1 beta 1 no longer has the field, which means it doesn't exist in the JSON anymore. And then I fetch it, and then now I don't have that field anymore. So so what we try and do in that case is either try and reconstruct that data. So maybe we've, for instance, we've deleted the field because we've got something better. Then what we can do is try and recreate what the old data might be based on our new better thing. So an example would be, I guess, I don't know if there's a good example of Cluster API, but one of the things we still have in Cluster API is phases. So phases is, you would say like a machine is ready and it goes from is being provisioned to ready, then running, and then I can't remember if there was another state after that. But what we ended up figuring out is that there's a lot more other different types of states that a machine might be in. And rather than filling up all those phases, we moved over to using conditions. Now, in a future release, we might delete those phases. But if an old client tries to fetch that machine and is relying on that phase, we might be able to reconstruct that phase from a list of conditions. So we might say that the definition of ready is when a bunch of conditions are satisfied, and therefore an older client can still carry on. So if you've built tooling, and us as VMware, we have tooling that when we started Cluster API relied on phase. So we have, and we've moved over to conditions. But if we were to remove phase and that product still relied on phase, then we might be able to reconstruct it on the conversion webhook. The other thing that we see is if we've added a field to a resource, then if I've added a field in v1 beta 1 now, and then an old client gets a v1 alpha 4 version and then makes a change and saves it back, then that old client didn't know that there's a new field, and that field gets deleted. So it goes missing. So we have a mechanism. So we have to try and preserve that data between round trips. And the way we do that is if an old client requests a newer version, we store a complete copy of the current version as an annotation, as a JSON annotation, such that when the client has finished with it and tries to save it back, if there's data missing on the old version, we can restore it from the JSON annotation as much as possible. And in most cases, that's easy. So the new thing that's appeared in v1 beta 1 is cluster class. So the topology bits are completely new. So if a v1 alpha 3 client goes and gets the cluster resource, they won't see the topology at all. And then they make a change and save it back. When it arrives at API server, all the topology information is gone. But because we stored all that information as JSON annotation, we can take that information back. So there's a load of helper utilities that do that in Cappy. And yeah, that's most of the stuff about how we do that's the complexity around conversions. And let's just see something example. Code organization explain could go here. Is that a suggestion that we update that document? Oh, yes.
Yeah,
yes.
Could be a good first issue.
Yeah, that's a good point. Yeah. Okay. Yep, good point. I think that would be super useful. Ashutosh.
I have one question that I'm confused about this one. So when you say this client that request, right? So the client is always going to request the stored version, right? For instance, kubectl.
kubectl will, but not necessarily. So, in our main.go, we've got those schemes, right? So we got the well, a user. I mean, a most common example would be you've written your own controller that's doing stuff, and they just happen to import an older version of the cluster API types. Yeah, thanks for that. Yeah, thanks. You could have said that to all. You didn't have to DM me that, Stefan.
Sorry, that was not intended. It should go to all.
All right, yeah. So most common example is you've written some layering controller on top of cluster API. It's importing an older version of cluster API types. Therefore, its scheme is necessarily going to request older versions. But as Stefan's noted, you can also do that in kubectl as well. Yeah, and he's just sent it correctly to everyone instead of DM to me. Yeah, so you can request the v1 alpha 3 types as well. But in general, yes, if you're using kubectl and you're not specifying the API version, it's just going to get the latest storage version.
So is this the reason we really don't need any migration strategy? For example, let us say I have a v1 alpha 3 CR, right, in current system, only one, and then we upgrade our components toward v1 alpha 4. I'm just trying to understand, is there anything that we actually need to recreate this v1 alpha 3, delete, and then install a new v1 alpha 4 CR, or just the webhook conversions will fine as you stated, because it mostly depends on client, right? It just fetches and just to and fro conversion happens.
Yeah, the way I would think about it is your migration strategy is written in your conversion to the storage version.
Right.
And that more or less is the migration strategy. So the API server will do it lazily. So it won't go and just update every. It will do it. It will do the conversion at the first get at the latest storage version. But yeah, I like to think about it that I write my migrations on the first write, not first get. So it's first write, it does the conversion. Really, I would have thought you did it on the get, just because if you've done the conversion, you might as well.
Well, as far as I know, it's only done on write, and there's something like storage migrator. I think they want to build a tool for the time when they actually will remove some of the core resources, because right now when they remove some older versions of, I don't know, deployments or so, they just stop serving them, but they're still there. And there's a tool called Storage Migrator, which I don't know when it will be done. But this tool actually gets all resources and writes them again, and thus it will trigger the storage migration. So it will upgrade all your resources automatically.
You're talking about Cube Storage version Migrator.
Yes.
Okay, there is one more like CRD migration tool. So I was confused, like, why we need all this migration then. So, but yeah. So one more question, other like you said, just to, we have an annotation in place in case, if an older client tries to add the newer field that was introduced in a next updated version, right? So just to make sure that that data is not lost, we put it into annotation. If, let us say, this is not an older client, the newer client happens to date, then we don't need to do this exercise, right?
No, so it's not so much that an old client is adding a field that's already there. It's more that they're making some other change in a V1 Alpha 3 compatible way, right? They're using fields that only exist in V1 Alpha 3. They got the resource. The V1 Beta 1 field is gone, disappeared, because it doesn't exist in the V1 Alpha 3 scheme. But annotations are always there, right? They always get the object meta. One of those. So we store the entire JSON of the storage version as the annotation. So that means when the resource comes back after they edit. So I guess very simple case would be, you've got some controller that some product or whatever, OpenShift, Tanzu Kubernetes Grid, the Weaveworks one, it only talks to V1 Alpha 3. It's got a web UX and someone changes the number of replicas, for instance. Probably not a good example. Well, no, that should work. I mean, it's a sub resource, so maybe it's not exactly the same. But some field, like just the number, or they change the Kubernetes version. They can completely do that with a V1 Alpha 3 thing as a resource. But we might be using cluster class or something as well. And all that cluster class information gets lost when they save the object. They might not be using they just do an update. So the update just doesn't have any of the V1 Beta 1 fields. But because the annotations are preserved, the conversion webhook can read the annotation back, said, look, we had all this topology information in the JSON. As it's coming back, I can save it back. So it's not that we're worried about an old client modifying a new field. It's modifying a field that's normal, but we're losing the information that we had in the newer resource. Does that make sense?
Maybe, then why did you mention like old client? Like if any client modifies the previous existing CR, this should happen, right?
Yeah, I mean old client in terms of it's working with a V1 Alpha 3 version of the CR.
Got it. Yeah, makes sense.
So old scheme. I mean, and the most common example is it's going to be an older version of a layering controller.
Right. Thank you.
Yeah, any other questions on conversion webhooks in general? Yeah, so I think in terms of what we're doing with the V1 Beta 1 upgrade, that's across the providers, that's mostly what we're doing. So because we're changing the storage version from V1 Alpha 4 to V1 Beta 1, and hopefully most of the providers haven't made any massive amounts. Well, you probably haven't made massive amounts of breaking changes. So you should be able to, what you currently have is going to be conversions where the conversion.hub is, well, basically this line here is going to be V1 Alpha 4 for your particular provider. That would need to be changed to V1 Beta 1. And the references in here, which are currently V1 Alpha 4, should be able to mostly swap them out to V1 Beta 1. Now, the issue you get then is the ordering of running conversion gen first, and if you've got dependencies between different resources, which is definitely the case in the Kappa. So in Kappa, we've got different API groups importing each other, which makes some of this tricky. So we'll have to take a look. Stefan.
Yep, maybe something other interesting to mention in this context is we introduced a new linter in the main repository, which goes over all those API packages and makes sure that you implement the right functions, convert to, convert from, and hub. So maybe at some point it makes sense to also use this thing in the providers. Right now we're just using them in the main.
This is this one, the conversion
Yes.
verifier.
Yeah, we missed at least, I don't know, 8 or 10 resources over the last years because what the most frequent errors is to forget to add functions like hub on your list types, and then the lists are not convertible. Yeah, and similar stuff.
Okay, all right, that's good to know. And do we just sort of run it like we're doing? It's just an executable, and you just run it in API directly.
Yeah, it's we just call it in the verify target. So there's in the make file there's something new like verify conversion channel or so, and it's just run on the verify target and on the verify job. And yeah, you can just run it. I think it detects, it goes over all packages from the root folder down, and it detects them based on, I think, the group annotation or something we have in those API packages.
Cool. Fabrizio.
Yeah, maybe worth to add that we have also fuzzer test, and those are crucial to basically ensure that your conversion works. Basically, fuzzer tests are they use a library from Google, and they randomize field, and then we call basically hub to spoke, and so all the combination of conversion that you can do, and we check that the result is what we expect, so we don't lose information during conversion. And this is crucial to see that everything works, and they are implemented in the API. There is a conversion test.
Yeah.
There is a utility for doing your fast conversion. So it is quite simple to implement them, and they are really valuable.
Yeah, so you'll find them in the conversion_tests in the main repo. So I think all the providers should be using them. If they're not, I'm pretty certain they are. Otherwise, the amount of problems that they've surfaced when we've done a conversion has been super handy. It will basically block you if you haven't done the correct conversion. So it's super useful. Any other questions on conversions? Cool. I guess then we take each of these controllers in turn then. I will probably have to lean on others for some of the newer stuff. Actually, probably makes sense to talk about topology later, I think, because it's you kind of, at least in terms of the nuts and bolts of how it works, you kind of need to know the other ones. So we'll come to that later, I think. But yes, so the cluster controller is every user's endpoint into cluster API essentially. And yeah, that's right. How deep do you want to go? Probably not super deep. So we'll probably cover cluster controller, MachineSet, machine deployment probably, and then maybe the Bootstrap one. I think the Bootstrap probably controller probably deserves its own little thing, because I think it's not well understood, I think, how machines actually get bootstrapped in general. So probably do one whole session on just on that one. And I did kind of say to the community that I would do one, because there was a lot of confusion in office hours a couple of weeks ago about how any of this works. Right, so yeah, so the cluster controller is everyone's entry point. So if we look at, I generally at this stage just go back to an example. So there's not, well, if we cluster class excluded, there's not a lot of stuff in your average cluster resource. So we have the pod networks defined, and then mostly we have the infrastructure ref and control plane ref, right? So what do we mean by that? So we got a reference to a particular infrastructure provider's cluster resource, and since V1 Alpha 3, a mechanism to have something to do create a control plane. Really, in terms of if I'm what's probably should have brought up a cluster. Well, how should I do that? Probably should go through. Should have prepared for this a bit better. Yes, we'll just go. I mean, I mostly see the cluster resource as being a holder of information. Oh. I'm looking at the wrong thing. So it's mostly a central control point. Certainly before the topologies cluster class didn't do massive. It was a synchronization point around storing a load of information, essentially. So it has information around. Why isn't this opening? Hold on. I'm waffling whilst I try and get something to open up correctly. Oh, am I not able to do this? Yeah, I mean, essentially the main thing about a cluster is it has a control plane endpoint, which is going to be used to connect to the cluster, essentially. So where is the Kubernetes API server going to live? So for AWS, it's going to be an ELB, and for vSphere, it's going to be the virtual IP of Kubernetes. Probably go into the particulars of those providers separately, and other controllers hang off of it. So the control plane controller hangs off of the cluster resource, and the way basically the cluster controller essentially waits for the infrastructure controller for the cluster resource to essentially become ready. And in terms of readiness, what we basically mean is that the network infrastructure is in a ready enough state to start deploying machines, and that there's a control plane endpoint. And after that, all the other controllers wait for a ready information on the cluster, infrastructure ready condition on the cluster to be able to then continue any other operations. So it's a placeholder for information is how I think about it, and a synchronization point. But on its own, it doesn't do a lot. And all the other controllers are actually doing the meat of the work, essentially. There's a bit of chat about CRD migration tools, but I'll leave them for now. Okay, so is there any disagreement from anyone, Stefan or Fabrizio, on my take on what the cluster controller minus topology does? I guess not.
I got distracted. Could you repeat the question?
Is there any I don't know, is there another take on what the cluster controller does other than mostly being a placeholder?
I think that the cluster controller main job is just to coordinate the cluster infrastructure provisioning.
Yeah. The next bit we have are, would it be more helpful to then jump straight into the AWS implementation of the cluster? Or yes, I see some nodding. So, all right, let's do that. Okay, so if the cluster controller is waiting for infrastructure ready, what does that mean in this specific use case? So again, the AWS cluster, at least in its default, doesn't have a lot of information, but it can have, there's actually quite a lot of configurable options on the AWS cluster resource. There just isn't by default. And there might be, let's take an example. I don't know if we've got some good examples. Yeah, this one, for instance, where you can specify, it's mostly around networking. So AWS cluster is essentially a network controller. It works with the Amazon EC2 API. So the Amazon EC2 API, I think is the second or third API that AWS launched back in 2009. And it started off, you had the ability to create EC2 instances in different regions, and started off in US East 1, which is West Virginia. Initially, there was big flat network that everyone lived in. So there's a flat 10.0.0.0/8 network in every region. Every customer in AWS shared that region. Yeah, shared that network. So you could, if you weren't being careful, it was quite easy to have your EC2 instances open to any other AWS customer, because all on the same network. And I believe DigitalOcean is still like that by design. So DigitalOcean is very much geared towards low cost developer machines. And in DigitalOcean, again, you want a shared network. So if you open SSH to everyone, you're open to, and you still say private IP, you still are open to every other DigitalOcean user in that region, I believe. I think that's the case still. In 2010, 2011, Amazon launched a new thing called Virtual Private Connect, and it's essentially a way to create your own private network separate to every customer. And it lives on the same API. So it's all lives on EC2. EC2 has its own endpoint. So the way Amazon works is every service for every region has an endpoint. So for Amazon, for EC2, that's going to be EC2 dot, I forget which way around it is, region.amazonaws.com. And this EC2 API controls the provisioning of machines, controls the provisioning of networks, and the provisioning of storage, and nothing else. We have another API for load balancers, and there's two of them now. But essentially, we talk with ELB, Elastic Load Balancer version 1, or otherwise known as Classic Elastic Load Balancers. There's a reason for that, going a bit later, but essentially, AWS Cluster Controller controls the provisioning of a network. It can either take an existing network, so you can say, I've already got a network, I've set it up using Terraform or my own custom tooling, please use it. Or you can let it create one from scratch, and by default, that's what it's going to do. So by default, it creates you a by default, it creates you a public network and a private network. It creates you a networking to go out to the internet. Yeah, hold on, just going to pause sharing. So got some other bits and pieces on it. Yeah, so we create a elastic load balancer for the API server. We optionally create a Bastion instance. So this is the way, so we have a SSH, a machine that you can SSH in from the internet and then get onto other machines. A NAT gateway, so NAT gateway basically translate is an ability for machines which are not directly connected to the internet to at least go and fetch things from the internet, into which we provision, well, other controllers are eventually going to provision some machines. So we have a private network. Anything that's launched in here is not going to have a public IP address. Anything in this network is going to have a public IP address. And into that, we put a elastic load balancer with, which is going to end up with a, by default, a public IP address that you can connect to from the internet. And why do we need this by default, at least in the sort of quick start experience, is because of the way Cluster API works, right? So we are running a bunch of Kubernetes controllers on Kind or Minikube or your favorite. You might be even having your own Raspberry Pi. Well, yeah, we do have ARM binaries. You might be running Raspberry Pi cluster that's running the Cluster API components. We're talking to Amazon APIs, so going out to the internet to provision some machines. And then we're going to need a way to be able to talk to these machines. So necessarily something has to be internet facing. Now, this isn't the case for everyone. A lot of people use Amazon VPNs. They might be using Amazon Direct Connect, or they might be provisioning inside EC2 itself. So they might have a Bastion instance inside EC2 onto which they then run Cluster API. And at that point, they don't need to necessarily go out to the internet. So in all of those cases, they can bring their own network infrastructure. They can bring their own VPC, and they can optionally say, we don't want any Bastion instance, or we don't need any load balancer. But in the most standard case, well, not most standard case, but the easiest case, the easiest thing we can do is to put an API server endpoint on the internet. It's secured. We're authenticating users via TLS certificates, etc. And we only present that API server. So you can't access any of these machines over the internet. You always have to go through this. You can use the Bastion instance optionally, or you can use another service like Amazon SSM Session Manager, which Amazon has a service where there's an agent that runs on all these machines. They connect to a service, and then you can talk to that service and jump onto those machines without needing any inbound connectivity, which we use in E2E testing, actually. So yeah, so the AWS Cluster Controller creates networks, it creates subnets, it creates security groups. So security groups are essentially firewall rules. So it creates 5 different security groups, depending on, there's one just for the control plane that only has the etcd ports open between them. So you can't connect the etcd from the worker nodes at all. There's a security group for the load balancer, which only has 6443 open. There's a security group for the load balancer, and only the load balancer is allowed to talk to the control plane on port 6443 as well. So the worker nodes can't connect to the API server outside of the load balancer. And then there's security group, and then there's a security group for all of the nodes that control things like CNI. What by default by default is for Calico. So by default, you get all the rules that work for Calico. and a bunch of host port services. So that's once that's done, and the majority of the time is taken provisioning NAT gateways, and everything else is fairly fast, while ELBs can take a while. So NAT gateways take about 5 minutes. ELBs can take up to 12 minutes, we've seen. So after that's done, we mark the cluster as infrastructure ready, and now other controllers can go and do things. And then we're now back into cluster API. So we've marked the cluster as infrastructure ready. Now that's happened, controllers that were waiting for infrastructure ready on the cluster can now do their thing. The first thing that happened, well, the first set of machines that are ever going to be created are the control plane. But if we're going to talk about control plane, we need to talk about machine bootstrapping. So we'll park that as one side. So we'll assume that we've got a control plane up at this stage. So if we do have a control plane, then the next thing that can come into play is the machine deployment controller. Now, actually, the machine deployment controller, I think only waits for infrastructure ready. I think it starts, what else does it wait for? Can't remember, but I think it actually sets off pretty early.
I'm not sure if it waits for anything.
It waits for control plane available.
Oh, okay.
Does it? I don't think it does.
I would have thought it's blocked because the Bootstrap controller waits for something.
Yeah, so I have a feeling it doesn't even wait for control plane ready. It just does it, and then the Bootstrap controller is blocked.
But you just see that pretty prominently in the code, I guess.
Yeah.
In the main reconciler, there's something.
That's right. Well, let's take a look. So, so we have, well, it's not actually a machine deployment controller that rolls out any machines anyway. So we have a machine deployment controller. And what's a machine deployment controller? It's the equivalent of a standard Kubernetes deployment controller. And what does a deployment controller do? It controls replica sets of pods. So you change the image version tag on the machine deployment. What does it do? It creates a new replica set with the new pod specification, starts off at 0, scales down the old machine deployment, replica set, scales up the new replica set until everything is rolled over. Machine deployment controller does exactly the same thing, except we're not working with replica sets, we're working with machine sets. So the machine deployment basically recreates the same functionality as the deployment controller, essentially. There is a bit of extra handling that it does. I can't remember for what. I think we've got support for different rollout strategies and bits and pieces. But essentially what it's doing is it's controlling machine set controllers. So the machine deployment controller never creates a machine. It only ever creates, destroys, and scales up and down machine sets. So if you're ever following the flow of like what controller is doing what, and you're looking through the logs, the machine deployment controller logs are not going to tell you much about what machines were created. It's the machine set controller. So if we, Ashutosh.
Yeah, Nadesh, so you mean that this controller, deployment controller is only going to create this machine set CRs, right? The resource. It's going to create, delete, and whatever according to it should be doing, and then machine set is the one who is finally going to talk to the AWS APIs to do the final job.
No.
Okay.
No. So the machine. So you're right. First bit's correct. The machine deployment is creating and destroying machine sets. The machine set controller, again, has no understanding of the infrastructure. Nothing at all. The machine set controller, just like a replica set, is going to create and destroy machines.
Got it.
And also it's going to create and destroy infrastructure machine. Yes, it is, isn't it? Yeah. So it's going to create infrastructure machines and machines. So what So yeah, you have a bunch of replicas in the machine set and bootstrap configs. That's correct. That's right. Yeah. So let's take a look at a machine deployment, shall we? So we're going to look at a machine deployment, and the machine deployment has a template and spec. It's going to, this machine deployment, once you create one machine deployment, it's essentially going to create one machine set, which is going to look mostly the same. So if we have a look at this, we've got a bootstrap config, which is referencing a template of some sort. And it just happens to be, in most scenarios that we think about, it's going to be a kubeadm config template. But just remember, not everyone is using kubeadm. So this could be something else. If you're on EKS, you're going to have an EKS bootstrap config template, because EKS does not use kubeadm. So we need another way to register the machines on the control plane. In fact, we are probably moving more towards what the EKS is doing in terms of our security, but that's it. Stefan.
In case of EKS, do you use the EKS Bootstrap, whatever it's called, only for the control plane or also for worker nodes?
There's no control plane nodes.
Yeah. So when you use the
Only
Bootstrap
for the worker
config,
nodes.
that's for the worker nodes. Okay, and the control plane is just the EKS control plane and no machine template.
Yeah.
Right? Okay.
So concretely, they're using the AWS IAM Authenticator project, which essentially what they're doing is they're proving the machine has been created by AWS. And then by introspecting the tags on the machine, it can be allowed into the cluster or not. And that is something we want to do as well, but in general for cluster API. So there is a proposal for the kubelet authenticator, which is going to move towards that model. So we're going to move away from what kubeadm does, but that you don't know what kubeadm does. So we'll have to do a session what that means. The kubeadm has a very specific mechanism of registering machines. We want to make that more flexible. We want to rely on the features provided by the cloud provider to ensure the machine identity. But that's a much deeper topic. So we have a kubeadm config template, but it doesn't have to be. The important thing is it's got template at the end. That's the important thing. And we have an infrastructure ref, which is AWS machine template. But neither the machine deployment, the machine set really knows what the meaning of an AWS machine template and kubeadm config template. As far as these controllers concerned, whatever's in here is mostly mystery. It's just a blob of information, and it's just like, yeah, sure, whatever, fine. And what happens in the machine set controller is I always forget about it. I always lose where it is. Oh yeah, I probably should have talked about the different reconcile loops. That would have been helpful, wouldn't it? Right. In terms of something written using controller runtime, the pattern that you will see is this. You will have a reconciler for each object type, and it's going to be set up with the controller runtime manager. And in this, first of all, we register that we're setting up a new reconciler. And it uses a builder pattern. So we're saying we're creating a new controller managed by the manager that we received from the main.go. And we're saying it's 4 machine sets. And the machine set controller is then going to own machines. So it's going to create, destroy machines. And we are also going to watch on, we want to create a Kubernetes watch on machines. And then we can hand in custom functions that can process these lists, the incoming notification API service. So a machine has been created. go and handle it. I think that's right. Yeah. You can pass in a bunch of options. You can also do some filters. So you can say, give me, I want to watch all of these, but maybe I only want to process them under certain conditions. So you can send in, so we have some helper libraries that then have the ability to not reconcile it if there's certain things on the annotations. And one of the reason I say that is because resource not pause. So you can put a pause annotation on any resource, and in that scenario, the reconciliation isn't going to happen. That becomes important. We'll probably have to do another session. Oh, I should make a note of what stuff we should be talking about in the future. Ashutosh.
Just a quick question. I don't want to maybe it will skip the agenda, but does this pause thing happens, or is it there to make sure this upgrade stuff goes seamless?
It's less about upgrades. It's more to do with cluster cut. Well, the reason it was originally implemented was for the purpose of cluster cut or move. Now you can actually put pause in two places. You can do it as an annotation on an individual resource, right? And there is a convention in Cluster API that a controller that sees that annotation will stop reconciling that resource. You can also set the pause field on a cluster spec, and if you do that, then there is another convention that all resources belong that are part of that cluster do not get reconciled.
Cool.
So the infrastructure providers have to implement that as well as core Cappy.
Yeah.
So you can essentially stop the world. And the most common use case for that is when we're moving the resources from one cluster to another. So if we do like a backup and restore, so we're backing up a cluster API from one cluster and we're restoring it to another. At that point, we don't want two different sets of controllers reconciling the same EC2 resources, but with two different copies of the Kubernetes resource, because then they'll just go completely out of sync.
Right.
And we do that in cluster cut or move. So when you're, if we're building a production cluster with Kubernetes, I don't want all my cluster API resources to be living on my Kind or Minikube on my laptop, right? Like that is that essentially becomes your single point of failure for the management of the cluster. So does that mean then you can't use cluster API for that initial cluster that is the source of truth for everything? No, it doesn't mean that. We can convert an existing cluster into a management cluster which runs all the cluster API components. But if we do that, we also want to move all of the resources across. And the way to do that is if you use, so in the cluster cut or move command, it can move resources from one cluster from a source cluster to a target cluster. And the way it does that essentially is by marking the cluster resources paused. It then traverses the cluster resource and all. I mean, Fabrizio is probably going to roll his eyes, so completely screw this up. But it follows the tree of resources that belong to a cluster, and I think it takes the entire namespace. Can't remember.
Yeah, but I get the idea. Yeah.
Yeah, pauses them, deletes them. So if you delete a resource, then you're going to have controllers if they're not paused, they're going to start actually deleting the infrastructure.
Right.
You do not want, like, I've just created a cluster. I don't want it to delete it now. So I pause it, delete it, put it in the new place, unpause, let the new management cluster catch up, and then carry on. So that's why that was the main reason for having the pause. It also turned out to be useful to have this pause annotation because lots of people do weird and interesting things that Cluster API doesn't do at the moment. Like they yeah, if you're doing, it's always telco, right? So if you're in the telco space where and nothing is really cloud native because they're not in any sense that anyone would normally consider cloud native. Like cloud native is about generic troll factor applications that you can run millions of copies of. That's not the case with telco. There's actual physical hardware that they need to plug in. In that case, they might need to they might need to get a machine created and then wire up some network, some radio access network card. In that case, they might want to pause it, turn off the machine, do something. It might even be human goes in, puts a card in, who knows, turns it back on, unpause, whatever. Like, yeah, all kinds of crazy stuff like that. So it's a whole bunch of use cases where, you know, we can't build the entire world into Cluster API. The pause turns out to be quite a useful escape hatch.
Yeah,
for a lot
I think
of those scenarios.
something similar I did for my previous project when, you know, upgrade was required, this pause thing. So yeah, I just wanted to understand, is it related to upgrade? Because so that leads to other questions. So during upgrades, do we have like downtimes when we do upgrade like cluster API or something like that? For example, if the workload cluster moves from a particular Kubernetes version, let us say 1.20 to 1.21, do we have downtime like for the workload cluster?
No, shouldn't do. No, it's not guaranteed. I think we'll have to cover that when we in the Bootstrap and kubeadm control plane. But the rules around upgrade is that you should never run a newer version of kubelet against a older API for Vizio.
I think that first of all, it is important to clarify that we have two types of upgrades. So one is the upgrade of the Kubernetes version, and the other is the upgrade of Cluster API itself. So we have these two kinds of upgrades. And let me say, if we focus on the upgrade of Kubernetes version, basically while a cluster is upgrading its Kubernetes version, Cluster API remains fully functional without any downtime, but also it happens for the cluster itself, because basically we add machine and then once the workload are migrating, we delete the new one. So there are no downtime for workload cluster and nor for the management cluster itself if it is self-managed and you are upgrading. Okay, so
but if the workload cluster is serving something, right, and if that is upgrading, the workload cluster itself could be in downtime, right? Because that's being upgraded.
Because basically what you do is that you have a workload cluster, you add and you want to upgrade for 121 to 122. That's need that first off you add a new machine 122. Then basically you start draining a node. And this basically moves your workload to the new one. Then once your workload are migrated, basically you delete the machine and you move on. So as far as your workload tolerate being drained, relocated with the usual let me say Kubernetes machinery, we are not causing downtime. If your the workload are not cloud native, then probably you have to walk in. But let me say, as Cluster API is not causing downtime to if everything is enough to work with a deployment, for instance.
Thank you, Fabrizio. That answers my question. Thanks a lot, Nadir, Fabrizio.
Yeah, so that's the case. There have been problems in the past, and this is due to insufficient testing. So you can't run a newer version of kubelet against the older API server. So we kind of enforce that by convention, like we do. But there is a brief period with because of the way kubeadm works. So when you're spinning up a new control plane, there is a brief moment of time where there is a newer kubelet with an older API server. So but it should be relatively brief and it should sort itself out, but it's not. There's been 1 or 2 problems about that in the past, but we have testing on the main branch of Kubernetes now. We do an upgrade to the main branch of Kubernetes, so that should more or less like track those issues. I think there's been some couple of issues where like a feature gate has been turned on to beta by accident or something, and like people haven't really thought through what the implications were. I think that was the last big one that occurred. I think that ultimately led to a new patch release of Kubernetes. So usually when those problems occurred, they highlight problems in Kubernetes itself. And that's why we are what's called SIG release informing. So we inform SIG release about the quality of the upcoming Kubernetes release. Or are we blocking? I can't remember.
Informing as far as I know.
Yeah.
Thank you.
So if there are problems, they will track us down as well. So you will see, like, you will see someone Slack you going, your E2Es are failing. Like, can you find out if it's a problem with you or is it a problem with us? Especially as we come up to releases. So it's good practice is if your provider is keeping an eye on your conformance testing for the main branch of Kubernetes, especially as we come up to the fun that is a release, a new minor release of Kubernetes, and everyone's scrambling to get their PRs in and test infos backed up, like and everything. Yeah, so help make SIG releases life easier, because the more we do that, the more confidence they have that Cluster API is a reliable signal, and the more likely they will keep us in scope for making sure that they are compatible with Cluster API and vice versa. So yeah, it's good to do that. Keep track of that. Make sure that we're providing good signal to everyone.
Yeah, thank you.
Right, so the MachineSet controller. So we have we have a way to process queues of resources that are coming in, so the work queue. And then you will see a common pattern in all of these. You will see a reconcile function, well, it depends how the code's organized, but yeah, so you'll definitely have let me just check. Yeah. Yeah, so you set up the reconcile, you'll always see a new logger being formed. So these are structured loggers. So that means the log lines will have the names of the resource, the kind, so it makes it easier to find out what's happening in your resource. A common pattern is, I mean, this shouldn't happen. Well, it might be someone's deleted a resource very quickly after it's appeared in work queue. Yeah, do some handling if the object's not found. So the first thing you can do in a controller is get that resource, match it with the cluster resource, check for the pause annotation and not do anything. Then we create this new patch helper. So what this patch helper does is we're going to be making modifications as we reconcile this resource to whatever resource it is. And we want to update the state on the API server. We just have this mechanism that any changes essentially save back up to the Kubernetes API server in the most minimal form. So we just patch the resource. We don't do a full complete update put of the resource. We only do the patch. Next thing you do is if resource deletion timestamp is 0, then we return. So MachineSet super simple, right? So if someone deletes a MachineSet, we don't need to do anything really. So we just return. So all this saying is if someone's deleted a MachineSet, do nothing and just return, let the user just finish deletion, and that's fine. And then if they're not doing a delete, then we're going to have a reconcile function. So you might have that. The AWS one, I think, has separate reconcile. So on the more complicated controllers, so if we're thinking about AWS controller and somebody's deleting an AWS cluster, then we now need to delete all of the resources. So we have a actual reconcile delete function as well. So we, in this one, if you once we get down to, yeah, so if there is a deletion timestamp, then we go through the deletion reconciliation. And yeah, so I think we'll probably have to finish after this one. So I will just go through this last bit, and I think we'll take final questions and call it, and then we'll maybe another session next week, same time, I suppose, and then we can go through the next bit. So reconcile external template reference. So as I said before, the MachineSet controller understands nothing about the particular infrastructure. All it knows is that you've specified a template of some sort. And what do we do with that template reference? So we set an owner reference on that template. Do we? Yeah, we do. Oh God, just closed it. And I'm missing the bit that I'm really looking for.
What are you looking for?
The stamping out of resources.
So when we actually create the machine and infrastructure machine, I think it's a little bit further down in the reconcile.
Was it up?
Also, yeah, so up from where you were, but down from where you started.
That's right.
Maybe get the machine.
Yeah, here we go. Clone template. So it's going to check the replicas. It's going to go through and check which machine. So it's creating machine resources and setting owner references. So owner references is how all these controllers are tracking what belongs to what. So as it creates machines, it's creating machines, setting the owner reference, AWS, the infrastructure machine, the template. So it checks the number of replicas. If there's a mismatch, and say it needs to create a machine, what it does is it clones the template. So what do we mean by clone template? Well, it's quite simple, really. It's pretty neat. So you assume that every template has a suffix of template. You can't put an infrastructure template, which is called, I don't know, AWS machine specification. That isn't going to work. It has to have template at the end. It's literally going to create a new resource. It doesn't actually know. It doesn't have a Go typed reference. It just knocks off the template at the end, creates a new resource with the same spec. It just copies the fields over, essentially. It will give a new automatically generated name, but apart from that, that's pretty much all it does. So this is why the MachineSet does not talk to AWS, does not do anything. All it does is create AWS machines and the Bootstrap config based on their template, but it doesn't really know what the template is, apart from the meta fields, essentially. That's why there's nothing it introspects from the spec. No, we don't have any common fields. Can be anything you like, isn't it?
You only need to have a template spec.
Yeah. So that's all we care about. And then after that, it's then handed over to the particular infrastructure machine controller and the Bootstrap controller. And I think will be our next session. Thanks. All right, so I will get a recording of this edited. I think there was one bit of proprietary information that flashed across the screen, which I will try and edit out in whatever equivalent of Adobe Premiere that I can find, and I will upload to YouTube. Thanks, folks.
Thank you, Nazir. This
Thank
was
you.
wonderful. This
Bye.
helped answer a lot of things. Thank you.
Yeah, thank you.
Thanks, Nadir.
All right.